Thank you very much for joining BDR and seeing how BDR transforms FHIR to meet healthcare regulations and needs. And some of the ways are significant regulatory requirements by CMS and HHS have mandated the use of FHIR for many forms of communication for the healthcare industry. HHS, CMS, HIPAA, CCPA, GDPR, and other regulations should be a substantial concern for C-levels and board members in the healthcare industry and any industry. The key to successfully meeting these requirements is to encrypt all the data in the FHIR database plus all the data in the FHIR Blobs, which are in a JSON format. The FHIR Blobs are the only complete representation of all the data in FHIR, including information not in FHIR's relational database. BDR will demonstrate how it delivers features missing in FHIR, yet required by regulators and regulations and desired by providers, data scientists, and analysts. This is being brought to you by Big Data Revealed, which we'll refer to as BDR. I am Steve Meister, the architect, designer, and inventor of this technology. Thank you. I will be stepping through this agenda, which will have numerous live videos being taken demonstrating the BDR additional features, graphical interface, and abilities and capabilities that it adds to the FHIR framework, which is added value for the healthcare industry. Now let's look at and discuss the features and capabilities delivered by BDR that make FHIR a more complete product. BDR delivers in days to weeks, literally, the key features needed by the FHIR framework to make your FHIR efforts complete and successful. Traditional designs and architectures of the past will fail when attempting solutions for FHIR. 1. For those providers with Medicare or Medicaid patients, which is about 40 million today and said to go up as high as 90 million in the next 4 to 5 years, you are now obligated by CMS, HHS to allow these patients to electronically access their healthcare billing and other information and to download this data to their devices, preferably securely. This must be accomplished while you continue to keep the data secure in the FHIR database and data at rest and in motion, and during the transmission of data to the patient's device. That could be an iPhone, an iPad, a computer, a server, most any device with a browser. BDR consultants can show how FHIR data can be accessed by data analysts to overcome FHIR's strikingly difficult restrictions on data extractions, which we will go into more detail later. FHIR was built to deliver one patient's information at a time, or one of FHIR's approximately 150 resources that, if combined, have over 27,000 fields and subfields. The exceptionally difficult structure of FHIR data make it very time-consuming to deliver data for multiple patients and very improbable for ETL, query, reporting, or other tools to create similar extracts for data scientists or analysts. Even FHIR uses intricate, complex, algorithmic processes in order to build a patient's data extracts. Now let's discuss why encryption of data in FHIR servers is the key to avoiding data breaches, ransomware attacks, and other compliance regulatory issues. For successful migration and ingestion of healthcare data into FHIR, the process must encrypt data at the point of the first contact and maintain that encryption until the data is placed into FHIR. End-to-end encryption for data in motion and at rest is crucial in meeting HIPAA, CCPA, CPRA, and GDPR regulations. BDR delivers end-to-end encryption of FHIR data and automates the review of data fields that might contain personal health information or personally identifiable information. BDR also encrypts all data in the FHIR Blob JSON format, as it contains all the data in the FHIR RDBMS plus additional data not found in the relational database system. Violating any of these regulations and allowing PHI and or PII information to be breached could mean many millions of dollars in fines, loss of customers, and damage to your brand and company's reputation. We will be showing examples of this encryption in the videos now coming up. Now we're going to take bulk bundled data and migrate it with the help of BDR and have it ingested into the FHIR repository. And as we see here, this is not encrypted JSON format HL7 type healthcare information. And again, this will be fully encrypted once it's ingested into FHIR repository. We're going to run a BDR job to do bulk bundle loading, and this can also be executed from the graphical interface. So while this is running, we see that the new repository is empty, but we're going to refresh it. And here we can see we are now accumulating data in the FHIR repository. So as we look at the different tables, we see that there's data, and we see that there's encrypted data where there would normally be decrypted patient and other resource type data in there. So here we can see that blobs are being written also into the database, which stores all of the patient data plus what's in the encrypted data in the database. As we open up the blobs in different rows randomly under different resource types, we can see that the data inside the blob is encrypted. Even though it's compressed normally in a zip format by FHIR, we have encrypted the compressed format. So this makes it in a breach unhackable, and we're using AES 256 encryption. And again, as we see, what would normally be individualized patient PHI and PII, it is safely encrypted, and here we can see the bulk bundle job has completed. Next, I will be showing and demonstrating the FHIR API URL calls to retrieve data for viewing and usage. Now remember, the data is encrypted at rest, as it is with us in motion, and the user would normally receive unreadable encrypted data by doing a basic API URL call to the FHIR repository. BDR will use BDR microservices and migrate in FHIR Interceptors to call to have the ability to display the encrypted data to the end user in a readable format. With any other query or reporting tool, or using FHIR out of the box, this protected, secured, encrypted data would not be readable to the end user or patient. So for transparency, I just want to go through showing the string data in the schema that we're going against, and we can see that the data is encrypted in the version table where the blobs are. The blobs are encrypted. So now we're going to go in with the Postman app, and first we'll look at all the patients' data and information. So as we click on this, it's just calling an API with the URL as anybody else would to look at the data within FHIR. But as we can see here, even though it's encrypted at rest, and it's still encrypted at rest, because of our calling of our microservices, we are able to see, read, and view this information and work with the information. Same as if we were to just look at a single patient's information. We can view it unencrypted due to utilizing the interceptors within Hibernate and FHIR to then be able to use our decryption and encryption capabilities, but always protecting the source data and maintaining that integrity by that data staying encrypted at all times, as I come over here and show you. That is the security in the pieces that have been overlooked by FHIR that's crucial to companies that want to meet HIPAA, CCPA, and GDPR and CMS requirements. FHIR was built to deliver either one patient's information at a time or data from one of FHIR's 150 or so resources in version 5. BDR developed microservices with Spark, Java, Spring Boot, Hibernate framework to allow enhanced processing of FHIR data for accuracy and scalability. BDR will shortly show in a video its flexibility, opening and creating a report or query against the FHIR server data. BDR may be the only application able to deliver this, as BDR has identified and mastered the internals of how FHIR uses its relational database management systems data, its blob JSON data, its linkage tables, and the intricate and complex procedures to combine FHIR data entries. One example of a needed query extract might be to determine how many patients have a specific disease or condition, what medications and doses they're on, the patient's gender, age, and weight, without even disclosing patients' personal information. Again, instead of just being able to process a patient at a time. Now I'm going to run a report and a query, but with our data at rest, still encrypted. We're looking at the BDR demo schema. The relational database information is encrypted. The blobs are all encrypted. We're going to go into the BDR app. We're going to go into BDR demo schema. We are going to go first, just grab a couple fields from the patient resource. We'll just do address and name information. And we'll search for name, give family name and given. We'll now go into the resource for observation, and we'll search for codes. And we'll search for subject. And at this point, we'll run the process. So that is running. That's going to create a report. Once the report has completed, we can then download that report or migrate that report, and then the report will be encrypted within the MySQL database, and we'll show how we can encrypt and decrypt that information. Now that the query or report has completed, we can view the information. There's server-side pagination to make the viewing quick as you scroll through. Now I am going to grab my iPhone and prepare it For the two-factor authentication, I'm going to select download. I am being prompted for a code 065728. I enter the code. It's then going to have me generate a key. This is an encryption key. It's used for crypto.js, SSL, SSH, our Spark job, BDR jobs, and HTTPS. I'm going to say done. I'm going to open the report. It stays encrypted, that report, until the point in which it hits my device, and now I'm able to view, save, and work with this data. Also, I can report or migrate this data to an existing database. So I have something called Steve Reports out in my SQL, and that goes into, we're going to use BDR FHIR, and let's take a look within BDR FHIR. Well, actually, we can put it into Steve Demo, and then tables. So we will come here and type in Steve Demo, and we'll create a new table called Steve New 08/29/2021. We'll test our connection, and we'll run the process. So what will happen is we will refresh Steve Demo, and shortly we should see our new table. Now, with the job completed and we refreshed, we should now see Steve New 08/29/2021 table was created, and it was created encrypted and securely, as it should be. Now, based on one's credentials and authority, they can then come into the jobs that were run, and it is encrypted, but they can come in and say, okay, I want to decrypt that data. Are you sure? Because if they have authority, they might want to do other movement. They want to maybe do some quick queries right against it, and then they can go back in and encrypt it as they should. There is some onus and responsibility on the users that have credentials, or they'll have to work with their DBAs to get redacted copies, or get permission, or have a DBA or somebody get them the unencrypted data. We'll go check on the job now and see if the decryption process has run. So we'll refresh. And this is the file that we created. And as I said, it creates them encrypted. Let's go back and look. Migration just started. I had thought that I had submitted the job. It is now running, and shortly we will look at the results. Now that the job has completed, it says decrypted, so we will go to the MySQL workbench. We will refresh the Steve New 08/29/2021. And there we have the decrypted table and values. Now, once again, if I'm a good user, I'm doing what I'm supposed to do, I will click on the action once again, and migration started, and the process is running, and shortly we'll go back and refresh, and the data should be once again encrypted. Now that the job has completed, we'll go back to the MySQL workbench, and we will refresh, This deep new 08/29/2021, and we see that the data is once again securely and safely encrypted. This is what we talk about, the capabilities of end-to-end encryption with Spark, Java, Spring, Boot, Hibernate framework, which is the same framework in which FHIR revolves around. Now, from an iPhone, we are going to connect with a secured HTTPS URL to the main server for BDR, like so. And we're going to be asked for a two-party authentication. We'll enter that in there. And then we are going to, once we're in there, set up a small little report as a patient, which is required by CMS to allow patients to get billing and other information. So we're coming in through the iPhone, no extra external iPhone application, all being done securely through SSL and SSH and BDR and Spark security. We're selecting the resources and columns that we want in our report that we want to download to our iPhone. It could be an iPad, it could be an Android, it could be any device that we want. And here we can see the job is running, and when the job is finished, we're going to view it, make sure it's what we want. We're going to request to download it, and we'll be asked again for two-factor authentication. And once that's entered, we're then going to have the file downloaded, encrypted in motion. It'll be decrypted when it hits the files within the iPhone, and then we'll be able to open up that file, look at our information, and do with it as we please, as it is the patient's information to do so. So now that the download has taken place, we're going to open up the file, and we'll put the phone sideways so we can see the data a little bit better. And there we have it. You're able to do it without an iPhone app. Lastly, we're going to show you one of the most important features of the Big Data Revealed BDR application. What you are going to see is a little query screen where we type in English, unencrypted data, and able to read encrypted data, match it, and bring back the information requested. And we're going to show you what would happen if you didn't utilize this proxy. So here we can see that email is encrypted. There's Lisa, her email is encrypted. We type in Lisa to do a query, and what do we get back? An email that's encrypted. Now we turn on and allow the use of the proxy that intercepts the database communication, and when we type in Lisa, we're going to get back the actual email because our proxy converted the encrypted to decrypted. We're even going to take the email address decrypted, do the search and look up, and we can see, and we got back the decrypted email as we thought we would. The last video demonstrates BDR's proxy microservices that allow e-commerce systems, websites, applications, APIs, and other programs to receive unencrypted data from users and have it interacted with encrypted data in a FHIR or another database. This allows for business as usual for your patients, analysts, scientists, and your company. BDR's proxy microservices keeps your sensitive healthcare data encrypted at all times so that you can be HIPAA, CCPA, CPRA, GDPR, and CMS compliant, and yet use the data as it was, if it was unencrypted. Your existing business and healthcare applications remain untouched and fully operational. What I really hope you come out with from this is in the review of key objectives and critical success factors implementing FHIR, our summary of implementing a successful FHIR server. Encryption of the FHIR server database and blob JSON data is really key. Allowing patients to access and download their healthcare data as mandated by CMS. Create flexible, open non-single patient related reports, queries, and migrations to support better business, marketing, and administrative analytics, and allow for scalable, flexible, and more accurate ingestion of data into the FHIR service framework. I thank you for taking a long time. It's been a long video, but this is a very, very important video to the C-levels, to your patients, to your providers, to your peers, to your partners. So just practice safe keeping of your data with encryption and allow BDR to assist in that process. Thank you and stay COVID safe.